than 3. That is, if we have an object or shape or form that is non-Euclidean, which is not describable by the geometry we know from school.
Height, width, depth.
Exactly, the geometry of Euclid. And if the dimensions were more than 3, we could not see them. There would be objects here around us. There would be real objects that we would not be able to see.
Certainly.
If you think that it is now commonly accepted, and we all know it, that the universe in its totality as a whole is not describable by Euclidean geometry and its dimensions are at least 4, you can understand that the forms and shapes created within it are not perceived by man.
Can you describe for us what these 4 dimensions are?
They are well known: length, width, height, time. For contemporary science, what we call time, what is referred to in the theory of relativity, and generally in all physical theories as time, has nothing to do with what we measure by our clocks and calendars.
Is it something different?
It is a dimension like height, width, and length. It is used in our equations in the theory of relativity as a dimension that in no way differs from the others. Under some circumstances, totally structured and limited in space and time, it can also be interpreted as common, measurable, human time. When, however, we study the universe and cosmology, we must not think that what we call time is what we measure with our watches. I told you that we cannot understand and perceive whatever exists in the universe with our senses, because there are 4 dimensions, and they are non-Euclidean. The question you could ask me is this: how then do I see chairs, objects? I see you, you see me, and we are parts of the universe. Mathematics provides for this and says that if I take the universe and cut a very small piece of it, an infinitesimal piece, this infinitesimal piece behaves with great approximation like a space described by Euclid. So this piece, this infinitesimal piece, behaves, without being so, like a space described by the geometry of Euclid.
In other words, a perceivable space.
Exactly. A classical example may clarify. You know very well that matter is composed of matter. The atoms are composed of electrons, protons, and neutrons. The electrons, protons, and neutrons, again, are composed of smaller elemental particles, which in their final form are nothing other than energy flow.
It is a wave.
Listen carefully now. Human senses have 3 disadvantages. First, let us take the eye. It cannot perceive all rays, all wavelengths, as physicists put it. We cannot see ultraviolet. The rays that our eye can see are infinitesimal in relation to those that exist. The second imperfection of our eyes is that they cannot distinguish as different objects that are located nearer than a particular distance. We see them as one. If there are 2 fires on a mountain and we go far away, we see them as one. And the third weakness of the eye is that it cannot perceive objects that are smaller than a certain magnitude. It doesn't see them at all. An example. Between us, there are specks of dust, immense amounts of material. Do we perceive it? We call it a vacuum. But it is not a vacuum at all. There is an infinity of material that we do not perceive because of its small dimensions. Just think if we did not have those 3 imperfections. What would we see? Would we see the table? No. We would see its atoms. we would see its electrons. We would see, even beyond the electrons, the energy flow. Whatever we see around us would be a soup, thicker here and thinner there. We would not have the perception that this is a table, that this is a machine, this is a chair, that is my pipe. We would see a boundless soup with condensations and dilutions. My eye takes these condensations and dilutions and creates the illusion of an object and of color. Let us now take touch. You extend your hand and say, "I am touching the table." You are not touching the table. The last structural material of your hand, the moment you say, "I am touching the table," is relatively at an infinite distance from the first structural material of the table. You never do touch it.
There is no contact?
No. What happens? Around the particles that make up the table, there is an energy flow, and around the energy flow of my hand, forces develop that are repulsive. So when I go to put these particles close to each other, they repel, and neurons convey this repulsion to my brain and convert it to what we call contact.
The message that reaches the brain is essentially an illusion.
Of course it is an illusion, for if I did not have these neurons, I might not have sensed anything. This means that everything in the universe communicates with its neighbor. In other words, we are not two objects that are unrelated to each other. We are united by an infinite material that we do not perceive, that is in between. We are all one in the universe. Whatever occurs at one point in the universe, because we are a soup, impacts the whole universe. It alters the whole universe. Whoever succeeds in giving you the definition of matter will receive a Nobel Prize. There is no definition, justified definition, of the concept of matter. Matter is a philosophical category. Many have developed different theories about what is matter. This philosophical category is the oldest philosophical category. I will tell you the three most prominent views. Basically, we believe that what we call matter is a condensation of the energy flow, to which I referred previously, that occupies the entire universe. Its condensations, wherever there is a condensation of energy, and this condensation of energy we perceive through our senses, as we said, as matter.
But we do not see it.
We perceive the condensation as matter. We perceive it as matter. The matter of my pipe is a condensation with the unitary universal flux. This condensation, our senses as they are made up, perceive as that formalism called matter. The elementary particle, as we say. In other words, the element of matter is nothing other than an energy whirl. A final view which prevails and is beginning to dominate in astrophysics is that matter is nothing other than space. It is a neighbor of time. I'll give an example. A veil, a spread sheet. I can understand nothing about matter from it. If I fold it somewhere, thus creating a curve in the sheet, my senses perceive that curve as matter. In other words, matter is nothing but space.
A curve in space?
A curve in space.
Does this have any relation to curved space-time?
Certainly, certainly. And we will see why we're saying all these things about cosmology and the density of matter and space and so on. So I have been talking about a curve in space, which in the language of physics is synonymous with a large condensation in the particular region. Whether we say a large condensation or we say a curve in space,